In this part of the video, we are going to deal with indefinite integration part 8. So before we exactly get into the problems on indefinite integration, let us have a quick recap of all the formulae what we have studied so far. So these are the ones what you have to go through thoroughly well. So these are the formulae which we have derived, or sometimes some formulae are direct consequence of derivatives, and there are some special integrals also in this. These are the special integrations of the special functions. So you have to go through these formulae thoroughly well before you exactly get into the problems on the indefinite integration of part 8. So the types of integration what we are coming across in this part are these. So integrals of the type integration of 1 upon a sin square x plus or minus b, or integration of 1 upon a cos square x plus or minus b dx, or the combination of both sin square and cos square. In all these cases, what the method says is divide the numerator and denominator by cos square x or by sin square x, and replace the sec square x by 1 plus tan square x or cosec square x by 1 plus cot square x only in the denominator. Keep the numerator as it is. Then the numerator will be converted in terms of either tan square x or cot square x. Then put tan x equal to t, so that sec square x dx will be dt in the numerator, or cot x equal to t in the denominator, so that cosec square x dx will be minus dt in the numerator. On simplification, the denominator will get reduced to the form either x square plus a square, or x square minus a square, or a square minus x square, and the problem becomes simple and easy to handle now. So the problems, for example, I have considered these ones. So first one, integration of 1 upon 4 plus 5 cos square x. Divide numerator and denominator by cos square x, and that becomes integration of sec square x upon 4 sec square x plus 5 dx. So only in the denominator. So this sec square x is replaced by 1 plus tan square x, and open the bracket and simplify that. That gives you integration of sec square x upon 4 tan square x plus 9 dx, and now put tan x equal to t. So the derivative of sec square x dx will be dt. So problem reduces to the form of integration of 1 upon 4t square plus 9. So we can rewrite it as 2t the whole square plus 3 square. That means integration of 1 upon 2t the whole square plus 3 square dt. And this is in the form of 1 upon x square plus a square. So the result is 1 upon a tan inverse of x by a plus c. So here 1 upon a is 3, tan inverse of 2t upon 3 into 1 by 2. This is 1 by 2 because of the coefficient of t. Then plus c. And now put back the value of t. So it becomes I equal to integration equal to 1 upon 6 tan inverse of 2 tan x by 3 plus c. So next one is integration of 1 upon 3 sin square x plus 4 dx. Again the rule is same, divide numerator and denominator by cos square x. So the denominator becomes 3 tan square x plus 4 sec square x, and the numerator will be just sec square x. So 3 tan square x plus 4 sec square x. 4 sec square x, this sec square x, only the denominator sec square x. This is written as 1 plus tan square x. So it becomes 4 into bracket 1 plus tan square x. So open the bracket, it becomes 4 plus 4 tan square x. So finally it reduces to 7 tan square x plus 4 in the denominator. So now we can put tan x equal to t. So derivative is sec square x dx equal to dt. So problem changes to 1 upon integration of 1 upon 7t square plus 4 dt. So this is further written as integration of 1 upon root 7 t the whole square plus 2 square. Again this is in the form of 1 upon x square plus a square. So 1 upon a is 2 here, tan inverse of root 7 t upon 2 into 1 by coefficient of t. So finally integration becomes 1 upon 2 root 7 tan inverse of root 7 tan x upon 2 plus c. So in this case we have got both sin square and cos square. Process is same, divide numerator and denominator by cos square x. So that becomes integration of sec square x upon 3 tan square x minus 10 plus 6 sec square x. So it becomes 6 is open taken inside the bracket, sec square x is replaced by 1 plus tan square x. So it becomes 6 plus 6 tan square x. Now this is the 9 tan square x minus 4. So now put tan x equal to t. Differentiate with respect to x. X square x dx is dt. The problem reduces to the form of integration of 1 upon 9 t square minus 4. And that is further written as integration of 1 upon 3t the whole square minus 2 square dt. So this is in the form of 1 upon x square minus a square. 1 upon 2a log of x minus a upon x plus a plus c. So 1 upon 2a is 2 log of 3t minus 2 upon 3t plus 2 into 1 by 3. This is the coefficient of t plus c. And now put back the value of t and simplify. It gives you 1 by 12 log of 3 tan x minus 2 upon 3 tan x plus 2 plus c. So next one, indirectly it is involved. It is involving cos square x. So where we have to put the formula of cos 3x. So it becomes 4 cos cube x minus 3 cos x. Now from the denominator we take cos x out. And on simplification it gives you integration of 1 upon 4 cos square x minus 3. And now now divide numerator and denominator by cos square x. So that reduces to sec square x upon 4 minus 3 sec square x. Now in the denominator sec square x replace it by 1 plus tan square x and take that minus 3 inside the bracket. So it gives you integration of sec square x upon 1 minus 3 tan square x. And now put tan x equal to t. Differentiate with respect to x, and that gives you sec square x dx as dt. Therefore I equals to integration of 1 upon 1 minus 3t square dt. So 3t square is written as root 3t the whole square, and now this is in the form of 1 upon a square minus x square, 1 upon 2a log of a plus x upon a minus x. So here it is 1 upon 2 into 1, a is 1. Log of 1 plus root 3t upon 1 minus root 3t into 1 by root 3 plus c. And now put back the value of t. So it gives you 1 upon 2 root 3 log of 1 plus root 3 tan x upon 1 minus root 3 tan x plus c. So this contains sin square x and cos square x. Divide by cos square x. Process is same. So it becomes x square x upon 13 minus 9 tan square. Directly got reduced to the form of a square minus x square. So put tan x equal to t, sec square x dx is dt. So that becomes integration of 1 upon 13 minus 9t square dt. And that is written in the form of 1 upon a square minus x square format. So that is 1 upon 2a log of a plus x upon a minus x. A is root 13 and x is 3t. So it becomes 1 upon 2 root 13 log of root 13 plus 3t upon root 13 minus 3t into 1 by 3. 3 is the coefficient of t. Plus c. So now it becomes 6 root 13 and put back the value of t. 1 upon 6 root 13 log of root 13 plus 3 tan x upon root 13 minus 3 tan x plus c. And the next type is almost similar to the previous one, but the difference you will observe now. So carefully observe it. So here we don't have squares, almost similar to that, but method is totally different. So in this case what the method says is put tan x by 2 equal to t, which is not available in the problem at all. It is not there in the problem at all. So put tan x by 2 equal to t. Therefore x equal to 2 tan inverse of t. Differentiate with respect to x. Dx equal to 2 dt upon 1 plus t square. Sin x is 2t upon 1 plus t square and cos x is 1 minus t square upon 1 plus t square. On substituting and simplification, the denominator will get reduced to the form of at square plus bt plus or minus bt plus or minus c, which is a quadratic polynomial, and this can be handled by one of the previous methods. If the denominator contains integrand of the denominator of the integrand contains sin 2x or cos 2x or both, in that case you have to put tan x equal to t. Therefore x equal to tan inverse of t. So differentiation of this is dx equal to dt upon 1 plus t square, and these two will not change. Sin 2x and cos 2x remain as it is. So let us consider And again, it will, after simplification, it will get reduced to the form of at square plus or minus bt plus or minus c, which is a quadratic polynomial. And you know how to handle those kinds of quadratic polynomials. So let us consider some example based on this format. So these are all the ones what we are going to consider. So first one, integration of 1 upon 5 plus 4 cos x dx. So put tan x by 2 equal to t, therefore x equal to 2 tan inverse of t. This is a standard substitution. Dx equal to 2 dt upon 1 plus t square, and cos x is 1 minus t square upon 1 plus t square. I'm not substituting, I'm not writing here sin x because there is no sign in the problem. So problem get reduced to 1 upon integration of 1 upon 5 plus 4 times 1 minus t square upon 1 plus t square, and dx is replaced by 2 dt upon 1 plus t square. And now here we will take LCM. So it becomes 1 upon 5 plus 5t square plus 4 minus 4t square upon 1 plus t square, and these 2 1 plus t square get cancelled and this 2 comes out. So we get 2 into integration of 1 upon t square plus 9 dt, and 9 is written as 3 square. So this is in the form of 1 upon x square plus a square. So that is 2 times 1 upon a tan inverse of x by a. X is t and a is 3. So it becomes tan 2 by 3 tan inverse of. So here it is 1 by 3 into t. T is tan x by 2 plus c. And here also the process is same. We are going to substitute tan x by 2 equal to t. Same substitution. So simplify it. It gives you integration of 1 upon 4 plus 4t square minus 5 plus 5t square upon 1 plus t square into 2 dt upon 1 plus t square. So this 1 plus t square 1 plus t square get cancelled. And why I have taken this problem is just to make sure that in the previous case we had plus sign and it was x square plus a square format. This is x square minus a square format. So 9t square is written as 3t the whole square, and 1 square is 1 square, and therefore it becomes 2 times 1 upon 2a, a is 1, log of 3t minus 1 upon 3t plus 1 into 1 by 3 plus c. So 2 to get cancelled, it becomes 1 by 3 log of 3 tan x by 2 minus 1 upon 3 tan x by 2 plus 1 plus c. Third one. And here we have integration of 1 upon 1 plus cos alpha cos x. Cos alpha is a constant because we are integrating with respect to x. So process is same substitution. Only thing is that numerical coefficient is replaced by cos alpha. And again the process also same. Once again it cross multiplied and 1 plus t square cancels. So 1 plus t square plus cos alpha minus t square cos alpha, that cos alpha is taken inside the bracket, and 1 plus t square get cancelled. And we made a small grouping here. So we have collected the terms which do not contain t in one part, and from the other part which contains a t, rather t square, and taken it out. So it becomes 1 plus cos alpha plus 1 minus cos alpha times t square. And we make use of the formula of 1 plus cos theta and 1 minus cos theta. That is 2 times integration of 1 upon 2 cos square alpha by 2 plus 2 sin square alpha by 2 into t square. So this 2 goes out and cancel with the 2 outside, and we are left with integration of 1 upon cos square alpha by 2. And from this what we have done is we have made it as 1 square. So t sin alpha by 2 whole square dt. And this is exactly in the form of 1 upon x square plus a square. So 1 upon a is cos alpha by 2, tan inverse of x is t sin alpha by 2 upon a cos alpha by 2 into 1 upon sin alpha by 2. This is the coefficient of t plus c. And now these two are multiplied, along with that I multiplied by 2 also, so that I get it as a 2 upon 2 sin alpha cos alpha. This is in the form of sin 2 theta. So it becomes sin alpha. Therefore 1 upon sin alpha is cosec alpha. And what the problem answer get reduces to is I equal to 2 cosec alpha tan inverse of tan alpha by 2 tan x by 2 plus c. So here method is same. Tan x by 2 equal to t, x equal to 2 tan inverse of t, therefore dx equal to 2 dt upon 1 plus t square. And here both sin and cos are there, so I have taken both sin and cos here. And on substitution it becomes integration of 1 upon 4 times sin x is replaced by 2t upon 1 plus t square. Here 3 cos x is replaced by 1 minus t square upon 1 plus t square plus 13, and dx is replaced by 2 dt upon 1 plus t square. So when you take LCM, it becomes, the rest will be same. This will be 3 minus 3t square, and this will be 13 plus 13t square. So we get it as integration of 1 upon 8t plus 3 minus 3t square plus 13t plus 13t square upon 1 plus t square. So these two 1 plus t square get cancelled and 2 goes out, and we get 10t square plus 8t plus 16. So 2 is taken out and cancels the 2 outside, and now 5 is taken out. T square plus 5t by 4t by 5 plus 8 by 5, and now we put it in the form of complete square. We adjust it. So t square 1 by 5 gone out, t square integration of 1 upon t square plus 2 into t into 2 by 5. So 4 by 5 is written as 2 by 5 plus its square 4 by 25 plus 8 by 5 minus 4 by 25, and that gets reduced to 1 by 5 integration of 1 upon t plus 2 by 5 whole square plus 36 by 25, 40 minus 4, and that is 6 by 5 whole square, and this is exactly in the form of 1 upon x square plus a square. So 1 by 5 times 1 upon a is 6 by 5, 1 upon 6 by 5 tan inverse of t plus 2 by 5 upon 6 by 5. So here 5 get cancelled, and we get 1 by 6 5t plus 2 upon 6, and now put back the value of t, and that gives you 1 by 6 tan inverse of 5 tan x by 2 plus 2 upon 6 plus c. Plus c is missing there, add it. So next is, this is the problem containing sine 2x. So put tan x equal to t this time. Therefore x equal to tan inverse of t, and dx is dt upon 1 plus t square. And we have got only sine 2x, so I have taken only the value of sine 2x. Sine 2x is again 2t upon 1 plus t square only. So it becomes 1 upon 3 minus 5 times 2t upon 1 plus t square. Dx is replaced by 1 plus dt by 1 plus t square. Sorry. And now it reduced to 3 plus 3t square minus 10 upon 1 plus t square into dt upon 1 plus t square. These two get cancelled. So it becomes integration of 1 upon 3t square minus 10t plus 3 dt. So again the process is same, take 3 out, t square minus 10t by 3 plus 1, and this 3 goes out, and this one we write it as a 2 into t into 5 by 3, t square minus 2 into t into 5 by 3. So b is this, b square is 25 by 9, add and subtract that, and that gives you 1 by 3 integration of 1 upon t minus 5 by 3 whole square, 1 minus 25 minus 16 by 9, that is 4 by 3 the whole square. So this is in the form of 1 upon x square minus a square. So the rule is 1 upon 2a log of mod of x minus a upon x plus a plus c. So it becomes integration of 1 by 3 times 1 upon 2a, a is 4 by 3, log of t minus 5 by 3 minus 4 by 3 upon t minus 5 by 3 plus 4 by 3. So 1 by 8, 3 get cancelled, log of t minus 3 upon t minus 1 by 3. So inside the bracket we can multiply and divide by 3. So that gives you 1 by 8 times log of 3 times t minus 3 upon 3t minus 1. And now put back the value of t, that is 1 by 8 log of 3 times tan x minus 3 upon 3 tan x minus 1 plus c. Again this is a problem containing sine 2x and cos 2x. So put tan x equal to t, x equal to 2 tan inverse of t, dx is dt upon 1 plus t square, and here we have got both sine x, sine 2x and cos 2x, and their corresponding values are written here, and substitute those two values. So it becomes the integration of 1 upon 2 plus cos 2x replaced by 1 minus t square upon 1 plus t square, sine 2x is replaced by 2t upon 1 plus t square, and these two 1 plus t square get cancelled, and it gives you 2t square minus t square plus 2t plus 3. So 3 is written as 1 plus 2 only, not added there. So that gives you t plus 1 the whole square plus 2 can be written as root 2 the whole square. So this is 1 upon root 2 tan inverse of t plus 1 upon root 2 plus c. Now put back the value of t. Therefore I equals to 1 upon root 2 tan inverse of tan x plus 1 upon root 2 plus c. And here we have got integration of 1 upon 4 sin x plus 3 cos x plus 3. You just observe the speciality of this problem. Specifically, I have taken this problem here because you can remember it for your competitive examination point of view. You can remember this as a formula also later on. I'll tell you what that can be reduced as a formula. Process is same. And now what is to be noted is, only note this point, coefficient of cos x and the constants are same. And if this is, rather if these two are same, you will understand what the problem will get reduced to, the format of. So sin x and cos x are substituted here, normal substitution. And on taking LCM, we'll get this. And now if you carefully note here, 1 plus t square cancels, and also this t square term get cancelled. So we get 1 upon 8t plus 6. And observe it carefully. 2 is taken out, it becomes 1 upon 4t plus 3. That means the problem is 1 upon a linear polynomial. It is not like 1 upon x square plus or minus a square type. Oh, this happens only when the coefficient of cos x and the constants are identical. And now this becomes 1 upon 4 log of 4t plus 3 plus c. And therefore the result is 1 by 4 log of 4t values tan x by 2 plus 3 plus c. Thank you.